Hello everyone, my name is Youxi, and today I'll be telling a story about a girl who first time dove into Reason world about 10 months ago and went on some adventure, then came back with some new ideas. And with surprise, the girl's name is Youxi. So about 10 months ago, I started my first Reason project in a professional setting, and I worked on it for about 2 months. So maybe actually a lot of you here today know more about Reason than I do, or maybe even just in programming in general. So a lot of things that might feel natural to you was like interesting problem for me. So for example, the very first thing I learned about Reason is it is a language we can compile to JavaScript. But it is also originated from a totally different language, OCaml. How does it work? Also, we have a React library for Reason, which is called ReasonReact. Here's some code example for ReasonReact. So in order to render some text, I need to wrap those texts in a double quotes. And on top of that, I even need to convert that reason string into a ReasonReact string. And similar thing in my table body, I'm trying to render some register values, but I need to convert a reason array to a ReasonReact array. What am I doing here? Why do I need to do all this kind of stuff? In React JSX, I've never worried about this. I don't even wrap my text in like double quotes. I just pass whatever string, a number, or array. It will just render. So I started to recall my previous experiences with other languages, like JavaScript, Python, Java, Clojure. They all kind of handle types differently, but they all eventually compile and they run on a computer. So a lot of small questions started to rise. What is a variable? What does type do? What do we mean when we say we're compiling a program? And what is actually happening when we are running a program? So all these small questions started to point this bigger question. What is programming? What is computer? So if I have all those small questions stuck in my head, why don't I just build one? Then I'll get all the answers to my questions. But, you know, emulating a computer is very, very complex, especially something like our modern computer, Mac. But what about something small and simple, a Game Boy? So Game Boy has all the core concepts like CPU, memory, and some display, button, and sound. Great, let's get started then. My adventure with a Game Boy emulator started. So chapter 1. First thing first, in order to build my Game Boy emulator, I need to picture what are the things I need to do and decide what are the tools I'll be using. So I'll need to probably display some graphics, and JavaScript seems to be a good candidate. I've implemented a lot of UIs with JavaScript.
WebAssembly, it's more performant than JavaScript code.
What? We didn't hear anything. So I was saying that other than graphics, I'll probably also need to handle some actions like user interactions, and JavaScript seems to be able to handle that as well.
WebAssembly, it helps prevent security issues like stack smashing.
Sorry. I was saying, other than graphics and user actions, we probably also need to handle some sound. And JavaScript seems to be
WebAssembly. JavaScript is not your only option. You can run WebAssembly on the browser.
Okay, WebAssembly. You got all our attention now. Who are you? So, how many of you have heard about WebAssembly? Oh, great. How many of you have actually played around with it? Cool. Great. So, what is actually WebAssembly? It is a new browser language. It is also a binary instruction format for a stack-based virtual machine. This is what that sentence meant. It's basically a file with big array of binary data. So compared to JavaScript, WebAssembly is a more performant language. First, because the file size is smaller due to its binary format. So the browser can download WebAssembly file much quicker than the JavaScript file. WebAssembly is also more efficient because the code itself is much closer to the machine code, which means the browser only needs to decode your WebAssembly file instead of parsing it. You can think of it as you finally can get rid of an interpreter between your code and the computer. Finally, WebAssembly is also more efficient because of this idea called streaming compilation, where the browser can start compiling your Wasm file while it's downloading the file, which is different from JavaScript. The browser needs to first complete downloading the file and then finally starts to compile it. So performance is not the only thing we care about in web programming. Security is also becoming a bigger issue now. And WebAssembly prevents security issues like stack smashing, which might not have really been a problem for higher level language programmers. But it has been a problem for lower level languages like C and C++. And actually, maybe this kind of security issue is scaring people away from diving into those lower level language world. So now, you might think the performance and the security of Wasm might sound good, but binary thing is not really your stuff. Not a problem. You can actually pick your favorite language and write your code logic and compile them to a Wasm file. It is actually a very exciting fact that WebAssembly is not only a new browser language, but it is also a language that a lot of other languages can compile into, which includes C, C++, Java, Python, Elixir, Go, and Rust. So, if WebAssembly is so great, why don't we just replace it with JavaScript? WebAssembly is still a very new language. It debuted only around 2015. And we need to keep in mind that sometimes the language ecosystem, like libraries, package management, is as important as the language itself. So compared to the big, widely established JavaScript ecosystem and community, Wasm is still very small. So at current stage, rather than replacing JavaScript, WebAssembly would work very well together with JavaScript. So tying back to my Game Boy emulator project, why am I using WebAssembly to build a Game Boy emulator? Learning a new language is always exciting and intimidating. Especially I'm already about to start a project that I know nothing about. But if I'm already starting a new project, why don't I just play with something cool and fun? I might get hangover later, but who cares? I'm young. All right, let's get started then. Chapter 2. So in order to generate a WebAssembly file, I need to pick a language that would compile the code into it. And I came across this language called Rust. So I've just randomly hearing a lot of people talking about it, and it sounded cool. Also, for my Game Boy emulator project, I will need to handle a lot of bits memory data. And the built-in structure like U8, which is unsigned 8 bits, is perfect for me to twiddle the bits. Finally, Rust looked very familiar to me. A lot of the syntax looked very similar to Reason syntax. So here is a code example. On the left is some of my Rust code for my Game Boy emulator, and on the right side is some Reason code from previous projects. So both of them requires predefining some types. And the way they define enum, objects-ish, and the way they define a type for a declared variable is very similar. So, what is Rust? It is a lower level language, gets compared to C a lot. It is a strongly typed language like Reason. And it is a language focused on performance, reliability, productivity. And it only has been around for about 10 years. And the 1.0 release was only 5 years ago, so fairly new language as well. And a fun fact, Rust is listed as the most loved language on Stack Overflow Survey 2019. So, and as a side note here, my perspective of Rust is heavily influenced by my previous experiences. I've never worked on any lower level languages like C, C++. My experience is heavily leaned toward front-end development. And I have some experience in Reason. So, when I first start a new language, I'm usually very curious about what does it look like learning this new thing? Diving into a statically typed world, like Reason Rust, from a dynamically typed language like JavaScript, is like you finally got a seatbelt in your car. You guys already got this? So, it gives you more safety, but also at the same time, there's some extra steps you need to take. And from now on, your movement is kind of restricted. So compared to JavaScript, there is a lot more extra keyboarding you need to do in Rust. And writing Rust code, all the types must be in sync across the entire project. There's nothing like, just let me make a small change here and I want to see the results, and I'll come back and fix all the other things later. No, you cannot do that. Rust would not compile for you. Also, learning Rust meaning you probably need to dig into the lower level language concepts. So what is the sales pitch for Rust? It is a unique language that has a complicated type system. It is a language that requires a lot more keyboarding, which as we all always wished for. And you need to dive into the magical world of unknown. Which sounds great, right? But hold on. I actually got some more exciting things to share. So one funny, but also actually very exciting fact is that I didn't really know that Rust is a lower level language for the first month when I was working on it. Or actually I knew because I read some introductory articles, but the experience was very similar to my first experience with Reason. So what does this mean? I must be a genius. Or maybe not. It is actually the friendly error message, the abstraction of memory allocation and deallocation, and the type system in Rust has helped me to learn those new concepts while building my project, instead of completely blocked outside from the Rust world. Here is an example of Rust error message. It not only tells you where is the error, but also tells you what is it wrong. So for example, the first error message It is telling you you're missing a field called screen canvas when you're trying to initialize this thing called canvas. So now you know what to do. Add a field of screen canvas. This is like coding with a personal coach, which is perfect for people like me who don't like reading hundreds of pages of documentation before I start a new language. Rust also has this amazing feature of abstracting memory allocation and deallocation. Memory management is one of the key concepts in lower-level language programming. It provides flexibility, but also at the same time introduces complexity. So the ideas like garbage collection came out, but it is a little bit out of your hand. For example, the JavaScript GC process. It pauses your program every now and then to go through the garbage collection process, but you do not know when it's going to happen, and you don't have control over if you want it or do not want it to happen. So Rust provides you this flexibility on abstract, predict, as well as manage, if you want, the process of memory allocation and deallocation. For the beginners, Rust is like, all right, buddy, I got your back. You just let Rust handle everything for you. But for the powered user, Rust will hand over all the control over to you. It's like, do whatever you want on memory stuff. It's all you're on your own now. So Rust, as we talked a little bit about, it's a strongly typed language. So if you're coming from the reason world, a lot of things should feel natural and intuitive for you. It got all those type benefits like exhaustive pattern matching, which would improve the correctness during the development phase. But on top of that, the type in Rust would help compilers to produce a more efficient result. The compilers can better optimize for stack heap memory allocation based on the type information provided by the Rust. So, there are a lot of other Rust features as well that I'm not going to talk about today. But one takeaway I want you to have is for reason people, Rust is a language that you can have a fairly smooth onboarding experience. We kind of talked a lot. What do we know so far? We know that Rust is a lower level language that compiles to WebAssembly file. We know that WebAssembly is a binary format file we can run on the browser. Also, instead of replacing JavaScript, WebAssembly would work very well together with JavaScript. So we talked about Rust, we talked about Wasm, but how does Rust, Wasm, and JavaScript all work together? Chapter 3. So I will be using Rust and WebAssembly for my Game Boy emulator projects, and the goal is to run it on a browser. But how can I run Rust and Wasm file on a browser? What does the process look like? Let's take a fuller picture of the ecosystem. First of all, I'll be writing my core Game Boy emulator logic in Rust. And that file gets compiled down to WebAssembly. And from there on, Rust job is done. From there on, it's the JavaScript and WebAssembly talking to each other on the browser. And my WebAssembly embeds all the core logics and memory data I implemented in Rust. JavaScript is mainly responsible for rendering some debugger UIs. So the JavaScript will need memory data from WebAssembly. And WebAssembly would probably also need to have some access to the JavaScript document object. But JavaScript, WebAssembly, they are two different languages. How can they possibly talk to each other? On the top is a code example of my JavaScript code trying to call some function get some data like cycles, a VBlank, timer, and in the bottom is my Rust code, which would eventually compile down to a Wasm file. It is trying to clear some screen, clear the canvas, as well as something is hidden there, trying to put some image on the canvas in the browser. So we need to handle the talk between JavaScript and WebAssembly. And because of the nature of WebAssembly, it is a binary format. We need to figure out a way to represent JavaScript types like string, Boolean, or integer in a binary format. We also need to handle the import and export of functions between JavaScript and WebAssembly in a way that they can understand each other. But thankfully, Rust provides this package called WasmPack, which generates a JavaScript and WebAssembly binding that handles all the talk for us. So in our JavaScript side, we just need to use those functions and write our normal JavaScript code. And from there on, we do not need to worry anything about the Wasm or the binary stuff. So a quick recap. We have Rust, which would compile into WebAssembly file. Rust also has package that will generate a JavaScript Wasm binding. And in the browser, our JavaScript and WebAssembly will be talking to each other through that binding. So, chapter 4. It has been about 4 months since I first started my Game Boy emulator project. And now I have about 6,000 lines of Rust code and 1,000 lines of JavaScript code. And so as we talked about earlier, in the Rust, Wasm, JavaScript ecosystem, my JavaScript is relying on the data returned back from the WebAssembly. So if there's any small change in Rust or Wasm, I need to go back to my JavaScript file and fix all my implementations. So for example here, I'm trying to render some value on register A by calling this function getRegisterA. That function used to return a string of 30. But, I'm just playing around in the Rust world, and now I decide to return a key value pair. So I need to go back to my JavaScript file and to go find all the places that I'm calling this function getRegisterA and fix the implementation for it. This is actually not such a big problem for me right now, but imagine if you are working in a team and on a fairly big code base. What you will need to do is to go search among hundreds of files nested in different layers. And if your coworker is reviewing your PR, they probably need to go through the same process. So it is a double or triple amount of effort. And then, after all, we might still miss one small place that's affected by our change. Now we are in a fun debugging process. So what we really need is a guardian that can help us detect all the affected code by the change. This reminds me of Reason. So I started to recall my first experience with Reason. There are a few things that I didn't like. I struggled with the steep learning curve in the beginning. I also didn't like the amount of extra keyboarding I had to do compared to JavaScript. I'm a lazy person. If I can achieve something with one keyboard press, why would I prefer 2 or 5 keyboard press, right? But to be said though, there are some features I really liked about Reason. For example, exhaustive pattern matching or nominal type checking. They are exactly what we need to solve the problem. It's like the guardian keep checking any type mismatch or any unhandled conditions across the entire project. This is like we finally, So if we can map our reason type into a Rust type. Then, whenever there's a little change in the Rust side, Reason will just tell us, hey, here's all the XYZ places you need to go and fix. Otherwise, I would not compile for you. This is like we have been trying to find a place in the city by playing Marco Polo with blindfold. But now, all of a sudden, we got a GPS in our hand telling us exactly where to go and how to go. All of a sudden, we spend much less time wandering around. Also, if Reason compiles for you, you can be pretty confident that at least you went go through all the affected code and you fixed for them. So, cool. To be said though, how can we introduce Reason into that Rust, Wasm, JavaScript ecosystem? It is actually not that complicated. In Reason, we have this tool called buckle script binding, which would allow us to use JavaScript functions inside of Reason. While Rust is already generating this JavaScript WebAssembly binding, we can just write our Reason binding on the functions that's exported from it and pass that to Reason. And eventually, our Reason will get compiled to JavaScript, which will be the file we are running in the browser. So here is a code example of my Reason binding for the Game Boy emulator project. So basically, it is one line for each function, defining what are the parameters and the returning data type. Not too bad, right? But by the way, Rust also generates TypeScript binding, which means TypeScript people do not need to write any bindings for themselves. So, if in the future, we can also generate some Reason bindings automatically, nobody needs to go through the process of writing bindings, like what I did. So, Rust, WebAssembly, they are powerful, they are fast, but handling UI stuff with Rust is kind of pain in the ass. But Reason has a great potential in it. So what about this a little bit more reliable, a little bit more performance, and fun Cyborg feature of humane Reason skin with a core, very powerful Rust and WebAssembly core? Thank you.